So welcome, Ben. I saw you had your sharing your screen.
Yeah, this is Ben Faber. Let's see.
Hey, there you are.
I'm supposed to share.
So I can remember. I think it's been a quarter century. Could it have been that I was at a field day where you were encouraging the growers to put mulch on their orange trees?
Yeah, no, I'm older than that.
I know.
So my background is in soil microbiology and soil fertility, and but I've been playing with organic matters as mulches for over 30 years, and it's been primarily to look at disease management within avocados and citrus, but also, potential impacts on pest management as well. So I wanted to talk about my own experiences and with organic matter, with mulches, with compost, to a certain extent with compost teas and citrus. And maybe that can result in some discussion topics that pop up as well. So I wanted to emphasize this whole thing about the soil food web that Greg and Emitter talked about. Ultimately everything is coming from the sun, and it's driving photosynthesis and organic matter production, the capture of CO2 from the air that, becomes the basis for, everything that is feeding in the soil and ultimately that is feeding us. And there's a back flow of this into the soil that actually feeds the plants. And so, plants are breaking down the soil, releasing nutrients, through their injection of carbon dioxide or carbonic acid in the soil that is one of the soil forming factors that releases these stored nutrients, that we call calcium, magnesium, iron, zinc, and so on, that are ultimately derived from rock, and but that becomes more available to plants, and this cycle goes on and on and on. I have been working on mulch, and this topic has come up about compost, and compost is not mulch. Mulch can be a compost. Mulch is anything that is applied to the surface, and this is more of a natural process that we see in nature. The plant grows, it drops its leaves that can be infected, or they could just be the natural growth cycle, drops it to the surface of the soil. You get insects and fungi and bacteria breaking it down and releasing what is stored there, and that then becomes available to the plant that's growing at that site. Composts are a material that has gone through a controlled biological decomposition. So compost is a material that can be applied to the surface as a mulch, but more typically it's applied as an amendment. It's incorporated into the soil, and then at some point plant roots can take that up. Amendments are inherently disturbing to the soil processes that are going. It accelerates process, it injects oxygen into the system, which accelerates decomposition and promotes bacteria. More stable environments have fungal dominant species. This can be good or bad, but this is characteristic of systems that are disturbed. You tend to find bacteria. In more stable systems, you find fungal components. Mulch, again, is a material that is applied to the surface and gradually works its way down into the lower soil or roots. Actually, when you have a nice mulch layer, roots will actually go up and start living within that mulch layer and taking nutrients directly from the mulch. So mulch has been around for a long time as a studied topic. These list some of the studies that were done at the Citrus Research Center that was used to be it ultimately became UC Riverside. And work was being done. I mean, in the ages prior to synthetic nutrients like urea and ammonium nitrate and so on, you know, we looked at organic sources, we looked at compost, we looked at manure, we looked at materials that were surface applied and often incorporated. And these were all studies that were being done to evaluate the effects of different sourced mulches on citrus production. And so some of these studies were looking at alfalfa and bean straw, manure. These are all byproducts of agriculture, or grown specifically to be applied on citrus. And so you see these yields, and you know, Greg mentions the, you know, how do you measure the impact of an applied material? Well, traditionally it was, you looked at the yield, and you know, the better yield, ultimately the better the input. These studies were often done, well, all of these studies were done before zinc was recognized as an essential nutrient. That was only back in the 30s and 40s. And oftentimes the nutrients recognized as being essential for a plant are often having been derived from studies that have been done on humans and animals. You look at, you know, how chickens and pigs and horses grow, and you find out, oh my goodness, so zinc is required. And then you apply those studies to plants and find out, oh my goodness, zinc is required in plants. Nickel was only identified as an essential nutrient in plants in the 80s. So we're still learning a lot of things about the nutrient requirements of plants still. So all these studies were done back in the days when there weren't a whole lot of micronutrients applied. And in fact, it was found later on in these studies that a lot of the results were because they were, the plants were zinc deficient. And the organic materials applied zinc at the same time as the other materials such as nitrogen, potassium, and phosphorus. So we have the opportunity to take large amounts of yard waste, and it's hard to take that yard waste and put it back into the gardens. Actually, all this yard waste should actually stay in the gardens and be recycled in people's backyards, but it's not. It's put out and accumulated, and then it's some way of putting it out into nature again has been sought. It's required by the law that yard waste be redirected from landfills, and a lot of this is being taken into agriculture now. So we're getting this mixed muck of stuff that seasonally is one thing. It could be highly grass dominated in the summer, and in the winter and spring when people are doing their prunings has a lot of woody material in it. Yard waste mulches are loaded with organic matter, and this is, you know, one of the limiting production factors I contend, and many others in agriculture. In Southern California, it's very difficult to get above a 2% organic matter level, no matter how much organic matter you put into the system, because it's driven by soil temperatures and moisture. And the more organic matter you put into the system, oftentimes you accelerate the decomposition, and you can hold a high organic matter level for a while, but it gradually diminishes. But we're putting organic matter into these perennial systems, and we're affecting the physical properties of the soil. We're changing water holding capacity. You know, again, these are mulches. They're applied to the surface. but their impacts are below the surface, and we're affecting the chemistry by adding the nutrients. So everything that a plant really needs to grow is actually in the decomposing plants. So the decomposing plant is releasing all the basic chemical nutrients that the plant needs, and it's supporting a microbial population through the release of, through the presence of organic matter. So in these perennial systems that I've worked in avocados and citrus, in general, we do not recommend disking. We don't want to incorporate materials because it accelerates decomposition, and it causes root damage. And so in Southern California, and this is probably true in general of California, we don't get rain. And so, you know, you hear about all these diseases that, you know, people are dealing with in Australia and high rainfall environments, and we don't get high rainfall environment disease problems. Yes, you know, Greg mentions some of these diseases that are associated with stone fruits and pome fruits that are related to high nitrogen, but in general, in citrus and avocados, we're not dealing with fruit diseases. We're dealing with root diseases. And the first line of defense for root diseases is don't disturb the soil. And so this goes back to why we recommend using mulches, where they're surface applied, and we don't disrupt the soil by disking. So most organic matter additions in orchards should be as mulches. We don't, in fact, we don't recommend organic planting mixes either, because when you create the planting hole and then you incorporate organic matter, the organic matter decomposes over time, and gradually a plant can sink below the surface, and that leads to crown rots. And also the issue is once you incorporate a large amount of organic matter on the base of a plant, you alter how water moves, and oftentimes it'll be wetter than it should be or drier than it should be. So we don't recommend incorporating organic matter into the planting hole even. So this is very commonly done in gardening situations, and we don't recommend that in a gardening situation either. So fine textured mulches tend to be great seed beds for weeds. So you can see right here, this is a trial that we did with citrus, where we were actually using a compost as a surface applied material, and pretty rapidly it gets invaded by weeds. And you know, weeds are, as they say, a plant out of place, and if you manage those weeds, you know, it can be a great source of organic matter. You know, the best way to get, the cheapest way to get organic matter into orchard systems is actually to grow it as a cover crop. And but in the case of using mulches in order to minimize weed growth, a compost is a very expensive mulch material. We're applying these mulches at 100 tons per acre, and this is just in the tree row. So we're only basically mulching citrus or avocados in about 25% of the surface area. So, and that's partly because mulches can have an issue with causing higher incidence of frost damage in the wintertime. Mulches cause a covering that prevents the soils heating up during the day in the wintertime, and can actually depress air temperatures and can potentially cause more frost damage. Anyway, so we're putting a lot of material on. We've found that over time that coarse textured materials are more persistent. They lead to some weed suppression and water conservation. And so this idea of persistence is important. We're trying to stabilize the system. We're trying to create an environment that is good for the roots, good for the tree, and we want those roots actually into the mulch, out of the soil where oftentimes we have disease problems. In fact, when we put out these persistent materials, we pretty rapidly, within 6 months or so, we'll start seeing a nice hyphal web of hyphae that are moving through the mulches and causing the decay and the release of the nutrients that are stored in those mulches. And actually, in the process of decomposition, they're creating an environment that is often quite antagonistic to pathogenic fungi. We also see that oftentimes the best situation for an orchard is a mix of cover crops. Here's a cover crop that was sweet peas that were being grown for farmers market sale, but it's a legume that's injecting nitrogen into the system. It's promoting organic matter, and at the same time using a woody mulch to suppress weeds and to conserve water. So back in the early 90s, and over a period of about 15 years, we did a whole bunch of studies looking at the use of materials as a mulch, or materials that were generated as a mulch material, but then were composted. And we'd look at these combinations of materials that were freshly ground, or freshly ground and composted. And we looked at these in different situations. And we looked at the materials from their nutrient standpoint, from their pH and so on. And one of the things that stands out is, here's an example of a material that was used as a surface applied material, or it was composted and then applied as a mulch. And you can see that freshly ground material has a certain pH, and when you allow it to go through controlled biological decomposition, it has another pH. You can see that there's some changes in what's called the electrical conductivity, and that's basically the salts, or basically the nutrients that are in those materials. And as you decompose the material, it releases the organic portion, and you get a concentration of minerals. And so basically decomposition is a burning process, and what you end up is ash, the mineral fraction. And as the material burns, it gains a higher bulk density. It's got more minerals, it's got less organic matter. So one of the characteristics of a freshly ground material is that it has a high organic fraction. It's higher than in a compost. So when you are using a composted material, you're using a material that has a high mineral fraction and a lower organic matter fraction, okay? And it's got a completely changed nutrient concentration. It's neither, again, everything that a plant needs comes from other plants. So if you grind up a plant, it's going to release those nutrients back into a system so that a new plant can take that up, or a new tree that has material applied to it can take it up. As you decompose that material, as you compost that material, you release the carbon fraction and you concentrate the mineral fraction. So a compost or a compostee is more of a nutrient in effect than a freshly ground organic matter. Although compost and compostees do have a bacterial fraction and often a fungal fraction that is higher than, say, a soil component of organic, fungi or bacteria. So when you're applying mulches, you're looking at a whole lot of different impacts on that orchard system. You're looking at disease suppression, you're looking at water savings, you're looking at nutrient applied, you're looking at weed suppression, you're having some impacts on arthropods. In the case of avocado thrips, you see an impact on reduction of thrips. You see snail effects. You see all kinds of things, and some of these are almost immediate. So in a normal drip irrigated or micro sprinkler irrigated system, you have this surface exposed that's wet, and you get a lot of evaporative loss. So as soon as you put a mulch out, basically you stop that evaporative loss, and the only loss of water is actually water that is going from the emitter through the soil into the tree and out the leaves. So basically, evaporative loss is reduced considerably. And this is represented in several trials that we did where we looked at mulched, unmulched citrus orchards, avocado orchards rather, in this case. And these dotted lines or solid lines represent tensiometer readings, how soil tension, and this is the soil moisture is under greater tension than it is in these ones that were mulched. So consistently, there's more water in a soil that is mulched than unmulched, which is, you know, in a Southern California situation where we don't get much rainfall, this is great. This is wonderful. There is the backside to that, though. If you're in a wet environment like, you know, New York or Maine or Canada where it rains all the time, New Zealand where it rains all the time, if you keep it wet all the time through mulching, you can increase in an environment that lacks air, and you get more root diseases. So I mean, there's a pro and a con to this, and in a dry environment like we have, we see mainly favorable results from water conservation by using mulch. So some of these impacts are really dramatic. We see in the case of snail control, this is a copper band that snails don't like to cross. Where we mulch, we do not see many snails at all. Snails don't like to cross a mulched environment. Where we see mulch, we don't see Argentine ant. We change the environment when we're mulching, and in the case of Argentine ant, it doesn't like that environment, and we'll often see a completely different suite of ants that show up in mulched environments. We'll see California fire ant oftentimes, which is not as much of a problem for biocontrol as the Argentine ant is. But more commonly, mulching impacts take time. Another almost immediate effect is on weed control. You know, you put a mulch out and weeds just don't like it. And with even a 1 inch or greater depth, you don't see many weeds growing in it. And this is, of course, a coarse mulch. In a fine mulch, you'll often see weeds show up pretty rapidly. Sometimes, most commonly, those are weed seeds that blow into the fine mulch. You see a change in the type of weeds that grow. The thicker it is, you tend to see fewer broadleaf weeds than grasses. One of the issues with mulches is that over time, the thickness decomposes, or it gets thinner, and that's because of decomposition goes on. So even with a thick woody mulch, needs to be amended. And one of the things that we've looked at primarily in avocados is that avocados are self-mulching. They generate their own mulch over time. And a lot of times the mulches are introduced, these supplemental mulches are introduced in order to kind of kickstart the system so that by the time the trees are 2 or 3 or 4 years old, they're generating their own mulch, and you don't need to introduce any further mulch. This is a chart that is showing the impact of mulching after 4 years. This was in an avocado orchard, and the impacts you see on the soil and on the tree are not always in tandem. So fairly, after 4 years, you start seeing differences in the nitrogen content between a mulched tree and an unmulched, phosphorus, potassium, and so on. But a lot of times you have a very delayed response that show up in the tree. So even though we saw changes in the soil here in nitrogen, you're still not seeing very much change in the tree in nitrogen, potassium, phosphorus, calcium, and so on. So when you're doing mulching, you're farming for the future in a way. You'll see these immediate effects on, say, ants and water conservation, but on the nutrient effects, it can be quite delayed. One of the things we do see, though, is pretty rapid colonization by fungi. And fungi are decomposing this organic matter. That's why it just disappears. And these fungi are, for the most part, well, these fungi are living off the organic fraction. And they're saprophytes, they're decomposers. And in order to break this down, they are releasing enzymes that are antagonistic to a lot of pathogenic fungi, such as oak root fungus and Phytophthora and Fusarium and so on. So it's creating a quite hostile environment to the pathogenic fungi. One of the things that we did over a period of 5 years was we looked at orchards that were mulched and unmulched. These were controlled trials where we'd have little plots and we'd introduce bacillus and pseudomonas and trichoderma and streptomyces to try and suppress Phytophthora. And I'd go out every month and I'd put out this soup of these beneficial bacteria and fungi. And wherever there was no mulch, I'd go back and I'd sample and I'd send the stuff back to the lab at UC Riverside, and they couldn't find it. Every month I'd go out and I'd introduce these beneficials, and you couldn't find it. And I'd put it all into the mulched areas, and pretty soon, once the mulch was there, it was producing its own antagonistic fungi and bacteria. So it's sort of like, put it out and they will come. The soil is a very difficult environment to change. It is what it is. And if you try and introduce a little bit of drips and drops, it's like spitting into the ocean. The soil is going to be dominated by what is there, and it is going to resist change as much as it can. It wants to be what is there. And it's, so you put out a whole bunch of mulch and it's going to support whatever is there. The most beneficial materials will come and they will dominate that environment, in that soil, in that water regime, in that temperature regime. And it's very difficult to change it through additions of small amounts of introduced materials. One of the things that we looked at too at one point was introducing humic acids. And humic acids again are humic acid is an extract of leonardite, which is a mined material, and it's got a pH often of about 8.2 or 8.6 or something like that. So it's not really an acid. It's the process of extraction that results in calling it a humic acid, but it's not really an acid at all. It's an alkaline material. And oftentimes we find that you can, if you're putting on enough to change that soil environment, you can raise the pH. And we're often dealing with very high pHs in Southern California, well, typically above 7, but 7.5, 7.6. And we're looking to try and reduce the pH. And one of the characteristics of most mulches and most decomposition of organic materials is the pH will drop. So this is through the release of carbon dioxide, and it's also the release of the hydrogen releases that come from the decomposition. So organic matters, generally speaking, through decomposition, acidifies soils. So here's an example of this impact of putting on materials, and we're looking at a mulch applied at the surface and then looking at its impact with depth into the soil. And we looked at the fungal populations that were growing in the mulch, mid-mulch, at the interface of the soil and mulch, and then deeper down. And we were looking at the actual fungal populations that were growing. Sheesh, I don't know why that's not stable. Anyway, where we had organic matter, we had a high level of population, and it had an impact within the soil itself. And that impact had an effect on the phytophthora. We were looking at how these mulches could suppress phytophthora. Now these are fungal populations within the soil. It's really diverse, and it's when you increase the organic matter content, that's what they're living off of. That effect will happen with compost as well, but it's going to have a much reduced fungal effect as a material that is freshly ground. And so this is often what we'd see in soils that there's a root at the lower base there, and we'd see very healthy roots growing in the organic fraction. So we also looked at wanting to understand the differences, impacts of mulches versus cover crops. And we in an area in Somas, we were looking at the impact of barley or a fescue medic cover crop versus a mulch. And we were looking at soil erosion, and over a period of time with different rain amounts, both the cover crops and mulches could have a significant impact on sedimentation. And so here we're looking at the most active fraction of the soil is this top 2 to 4 to 6 to 8 inches that Greg was talking about. That's where the highest turnover of nutrients is. That's the environment that has the highest diverse fungal population, bacterial population. And the more you can protect that surface layer, the more healthy the trees are going to be. And we found that in the case of both cover crops and mulches, we could significantly reduce erosion. So what are some of the problems associated with mulch? Well, early newly applied mulches can lead to a nitrogen deficiency, and that's because to break down the organic matter, you need bacteria and fungi, and they are going to scrounge for nitrogen in order to put into their bodies in order to break down. Eventually, within 3 to 6 months, though, there is a net flush of nitrogen that can be uncontrolled. Greg referred to the release rates of compost of nitrogen. California soils in general, certainly Southern California and coastal California soils, pretty rapidly break down organic matter. Compost, you know, we talk about slow release organic forms of blood meal and stuff like that. Fish, you know, if you have moisture and if you have the warm soils that we've got, you have a pretty rapid release of nitrogen from organic sources. And we did some studies Mark Gaskell and I up in Santa Barbara looking at a variety of organic sources, compost, and a lot of it's released within 6 months. So organic sources of nitrogen can be pretty rapidly released in our environment. But in the case of mulches, you can have excess moisture buildup. You can have, because of the release of nutrients, you can have delayed hardiness, so can cause more frost damage. Definitely you can see rodent damage. Mice love to hide in mulches and come out and chew on trees. It's potential introduction of new weeds, and it's very expensive to apply. We prefer woody materials because of the persistence they can provide. And if these are yard waste, a lot of times you'll get introduction of palm seeds, pine seeds, and eucalyptus. And sometimes you'll get tomato seeds being brought in with mulches. So you gotta, watch that material as it comes in to make sure it's clean. This is an example of rodent damage that happened in citrus where we were mulching. These meadow mice can cause real problem. Mulches are expensive to apply. In the early days, it was all hand applied. Now there's a lot of good machinery applications that on flat ground run about $300 an acre. Once you get into steeper slopes, though, you still have to do hand applications. And a lot of trials have been done to diminish the cost, but mulch is expensive to put out. And you got to watch out for trash. It's a lot cleaner than it used to be, but it can be a real problem. So this is my summary slide. In going from coarse, fresh materials to composted materials, some things gets lost. One of the things is you get decomposition, and so the organic fraction is given off as CO2. You can often lose a lot of nitrogen that way as well. You tend to accumulate salts, which is good stuff. We talk about salts as being bad, but the plants are taking up potassium bicarbonate. They're taking up calcium bicarbonate. They're taking up, these materials that are coming from the decomposition. And these are salts, and if they're in too high a concentration, they can be a problem. The pH can change significantly. A lot of times composts have a higher pH, which means there's more bicarbonates and carbonates present, because these are the decomposition byproducts of burning, essentially. And as you create a compostee, you're really putting on a very dilute form of some of these nutrients. That can be used as a foliar. It can be used to be injected through an irrigation system. It is very dilute. And the more frequently you apply it, the more likely you're going to get concentrations that are adequate to meet the needs of the plant. I'd like to underscore again what Greg said, that the more frequent small amounts of materials you can apply, especially of nitrogen, the lower amounts, total amounts you can use. In avocado and citrus orchards, it was not uncommon to put on 200 pounds of nitrogen a year. And in a lot of cases in the last 10, 15 years, growers have reduced nitrogen to, in the case of avocados, to below 80 pounds per acre. And a lot of citrus growers are in the 120 pounds of nitrogen. So there has been changes. People are learning how to manage the systems. Going from furrow flood irrigation to micro sprinklers to drippers. These are new systems. People are learning how to use them, and we can better manipulate these materials with these new systems. So with that, I'd like to open up possibility of discussion? If not,
we have a couple questions that have come in. So the first one is there any organic material that you would not use as mulch? And I guess if you could, elaborate on that, of any better or worse ones that are out there.
Yeah. So there's a lot of mythology out there, and some people say don't use eucalyptus, don't use oleander. Anything that's organic is good. And these ideas that you get these antagonistic materials that are in plants. The pine needles are acidifying. Pine needles are no more acidifying than other needles. Pines grow on acid soils, therefore, and a lot of plants can't grow on acid soils. So you'll find an acid soil around a pine tree. But we've done a lot of work with things like pine needles and eucalyptus, and any of those are good materials as a mulch. Anytime you incorporate materials, as you might with a compost, anytime you amend a soil, then you have to watch out for things. You've got to use a really good quality compost if you're incorporating and you want it to come into contact with roots. But as a mulch material applied to the surface, it's going to break down. It decomposes in place and releases its constituents. There are things that I want to stay away from. Goat head weeds. Some things you just don't want to put out there because they're going to be problematic. But as a mulch, chip materials that are put out, I'm not aware. I mean, mulch materials can be, concrete and carpet material and newspapers and all kinds of things. So
I think you've kind of answered this, but the next question was in terms of multiple sized and shaped aggregates. Is there some better or worse, or is it best to be uniform in size?
No, nothing is going to, I mean, you're trying to get material out there cheaply, so you're going to get something 1 to 2 inches. You don't want to have big stuff that you're going to trip over. Fine materials break down too fast, and roots adapt to this mulch material, and so you want to keep a stable environment. So you don't want to have something that's going to be like grass and go away real fast.
Mm-hmm. And then a new one just came in. Will mulching change the pattern of wetting from a drip emitter in a beneficial way?
Yeah, it depends on where you put the drip emitter. So if you put it on the surface of the mulch, the mulch itself is going to diffuse the wetting pattern. If you put it under the mulch, which is the best way to do it if you want to conserve water, but then you can't see the damage or clogging or anything like that, it's going to take on the pattern that the soil itself allows. So, a coarse textured soil is going to have a more downward flow versus a clay soil that's going to have more outward flow.
Mm-hmm. And now, is it necessary to maintain a distance from the trunk?
Absolutely. You need to keep 3 to 6 inches or so away from the trunk. Mulch materials, even in avocado orchards, if you keep mulch up against the tree, it can lead to crown rots. And this is true all trees can be affected by crown rots. And crown rots are often mild pathogens that become aggressive once you could create a wet environment all the time. Mulches conserve water, and that can be detrimental.
Okay, he's just come on.
And you said optimal depth, you said is around 2 inches? Was that?
3 to 6 inches.
3 to 6 inches. Okay. And another question that for a home gardener, why do people say keep citrus leaves off the bottom of citrus trees?
Does that mean keeping the canopy pruned up, or?
I'm not sure. Maybe any of the leaves that fall. I don't know.
One of the worst things I ever heard, I got a phone call from somebody down south that they'd just raked up 5 acres of leaves out of their avocado orchard, and they wanted, what do they do now? And I said, put them all back, man. What are you doing? Mulch is natural, and you know, unless you've got some weird disease, and, you know, Annemiek was talking about, you know, cleaning up, trying to reduce disease. We don't have very many diseases that cause canopy and fruit disease. I mean, HLB is badass. I mean, this is invasive. It's creating real problems. I don't know really if mulch at all is going to affect HLB, but you want to keep mulches out there in general because that's the nature of trees. They want their mulch.
Okay, it looks like that's all the questions we have here for right now. If anyone has any additional questions, just feel free to fill them in the Q&A box there. Well, okay. Thank you so much, Ben.
Yeah, it's a wonderful, wonderful presentation. I think I could listen to that a couple more times, Ben. Thank you so much.